Tonight, we're going to talk about one of the greatest journeys humanity has ever attempted. In 1977, two robotic spacecraft left Earth, carrying the hopes, intelligence, and curiosity of an entire civilization. They were never expected to survive very long. Engineers believed the mission might last 5 years if everything went perfectly. But nearly 50 years later, those same machines are still alive, still traveling, still communicating, still moving farther into the darkness beyond the planets. Tonight, somewhere unimaginably far away from Earth, Voyager 1 and Voyager 2 are still crossing the silent ocean between stars. They have traveled farther than any object humans have ever created. They witnessed worlds no human eyes had ever seen before. And what they discovered changed humanity's understanding of the solar system forever. By the end of the story, you'll understand why the Voyager mission is considered one of the greatest scientific missions in human history. September 5th, 1977, Cape Canaveral, Florida. A Titan Centaur rocket waits on the launch pad, carrying a spacecraft roughly the size of a small Voyager. But Voyager 1 was not the first spacecraft launched in the mission. 2 weeks earlier, on August the 20th, Voyager 2 had already left Earth on a different path through the solar system. The numbering seems backward at first. Voyager 2 launched first because it was following a slower route that would eventually allow it to continue farther into the outer solar system. Voyager 1 launched later on a faster trajectory and would eventually overtake its twin. Both spacecraft were originally built with a relatively simple objective: travel to Jupiter, travel to Saturn, take photographs, collect scientific measurements, then continue drifting endlessly into deep space. That was the mission. 5 years if everything worked correctly, maybe less if something failed. At NASA's Jet Propulsion Laboratory in Pasadena, California, engineers understood they were attempting something extremely dangerous. No spacecraft had ever traveled through the outer solar system before. Nobody knew exactly what conditions the spacecraft would encounter. Jupiter's radiation environment was powerful enough to destroy electronics. The deep outer solar system was unimaginably cold, colder than almost anything humans naturally experience on Earth. And the farther Voyager traveled away from the Sun, the weaker sunlight would become. Eventually, sunlight would be too weak for ordinary solar panels to function at all. So the engineers designed Voyager differently. Instead of solar panels, each spacecraft carried 3 radioisotope thermoelectric generators, usually called RTGs. These devices produced electricity using radioactive decay. Inside the generators, plutonium-238 slowly released heat as it decayed naturally over time. That heat was converted into electrical power. No sunlight required, no dependence on solar energy. As long as the plutonium continued generating heat, Voyager would continue receiving power. The system was simple, reliable, and capable of lasting decades. Each spacecraft carried 11 scientific instruments: television cameras to photograph planets and moons, infrared and ultraviolet spectrometers for studying atmospheres and chemical composition, magnetometers for measuring magnetic fields, cosmic ray detectors for studying high-energy particles arriving from deep space, plasma instruments for analyzing the solar wind. Every instrument had a purpose. Every instrument represented years of scientific planning. But perhaps the most extraordinary thing about Voyager was not the spacecraft itself, it was timing. In the late 1970s, the outer planets aligned in a rare configuration that happens only once every 175 years: Jupiter, Saturn, Uranus, Neptune. All positioned in a way that allowed a single spacecraft to travel between them using gravity assists. The idea sounded almost impossible. A spacecraft could fly close to Jupiter and use the planet's gravity like a slingshot. Jupiter's enormous gravity would accelerate the spacecraft and bend its path towards Saturn. Then Saturn could do the same thing, then Uranus, then Neptune, each giant planet acting like a gravitational accelerator. This became known as the Grand Tour, a once-in-a-lifetime opportunity to visit all 4 outer planets with a single mission. But NASA originally didn't have enough money to fully approve such an ambitious project. Officially, Voyager was only designed to visit Jupiter and Saturn. If the spacecraft survived longer than expected, and if NASA approved additional funding later, then maybe the mission could continue beyond Saturn. Maybe. Even reaching Jupiter required extraordinary precision. The distance between Earth and Jupiter constantly changes because both planets orbit the Sun. At its closest, Jupiter can be roughly 390 million miles from Earth. At its farthest, around 600 million miles away. Voyager had to launch at exactly the correct moment. A tiny error in timing could completely destroy the mission. The launch window was incredibly narrow. Miss it by a few weeks, and the spacecraft might never intercept Jupiter correctly. Engineers calculated Voyager's trajectory years before launch. They accounted for the gravity of the Sun, the movement of Earth, the motion of Jupiter, rocket thrust, tiny gravitational disturbances, every small force acting on the spacecraft. One slight mistake could send Voyager millions of miles away from its target. The precision involved was astonishing. Meanwhile, NASA's Deep Space Network prepared to maintain communication with the spacecraft. The Deep Space Network consisted of enormous radio antennas located in California, Spain, and Australia. These giant dishes continuously tracked Voyager across the solar system. The main antenna at Goldstone, California, stretched 230 feet across, almost the size of a football field. And these antennas were unbelievably sensitive. Voyager's radio transmitter used less electricity than a refrigerator light bulb, yet billions of miles away, Earth could still hear its signal. The signal arriving from Voyager was so weak that engineers compared it to detecting the energy released by a snowflake touching the ground. That's how faint the transmission was. And communication delays quickly became enormous. At Jupiter's distance, radio signals travelling at the speed of light required about 45 minutes to travel one direction. If Mission Control sent a command, engineers had to wait 45 minutes before Voyager even received it. Then Voyager processed the command and transmitted a reply. Another 45 minutes passed before Earth received the response. A simple exchange required an hour and a half, and things became even slower farther away. At Saturn, round-trip communication exceeded 2 hours. At Uranus, more than 5 hours. At Neptune, over 8 hours. Eventually, once Voyager entered interstellar space, communication delays stretched to nearly 2 days. That meant Voyager needed to survive independently. It could not wait for Earth to solve problems. If a computer malfunctioned, if the spacecraft drifted out of alignment, if an instrument failed, Voyager had to recognize the problem and protect itself automatically. The spacecraft carried redundant systems, backup computers, backup electronics, backup communication systems, automatic fault protection software capable of shutting down instruments and stabilizing the spacecraft until engineers on Earth could respond. Voyager had to think for itself. It had to survive alone in deep space. Then came Jupiter. Voyager 1 reached the giant planet on March 5, 1979. Weeks before arrival, images already began reaching Earth, and immediately, scientists realized they were seeing something extraordinary. Jupiter was unlike anything humanity had ever observed up close. The Great Red Spot appeared in stunning detail, a storm larger than Earth itself, a gigantic hurricane-like system raging continuously for centuries. Bands of clouds wrapped around the planet in violent patterns created by Jupiter's rapid rotation. The planet spins once every 10 hours, despite being enormous. That rapid spin creates powerful atmospheric jet streams moving at incredible speeds. The atmosphere looked alive, violent, chaotic. But the biggest surprises were waiting around Jupiter itself, its moons, especially Io. When Voyager turned its cameras toward Io, scientists immediately realized something was strange. The moon looked completely different from every other moon humanity had previously observed. Most moons are grey, dark, covered in impact craters accumulated over billions of years. But Io exploded with colour. Bright yellows, deep oranges, strange red regions. Sulfur compounds coated the surface in alien colours. And there was another mystery. Impact craters were almost completely absent. The surface looked young, fresh, as if something continuously reshaped it. Then came one of the most important discoveries in planetary science history. Linda Morabito, a navigation engineer working with Voyager images, noticed something impossible while analysing photographs of Io. A bright plume extended outward beyond the edge of the moon. At first, she assumed the image was corrupted, maybe a processing defect, maybe a camera glitch, maybe a cosmic ray strike. But after examining additional images, she realized the plume was real. It was a volcanic eruption. An active volcano exploding on another world. March 1979 became the first moment in human history when humanity witnessed volcanic activity beyond Earth. The discovery shocked scientists around the world. Io was small, roughly similar in size to Earth's moon. Small worlds are supposed to cool down quickly after formation. They lose internal heat and become geologically dead. Yet Io was erupting violently, and Voyager soon discovered it wasn't just one volcano, there were many. By the end of the flyby, scientists identified 9 active volcanic eruptions occurring simultaneously. 4 months later, Voyager 2 arrived at Jupiter and examined Io again. Most of the same volcanoes were still erupting. Some had stopped, new ones had appeared. Io was not occasionally volcanic, it was constantly erupting. Gigantic plumes launched sulfur and sulfur dioxide hundreds of miles above the surface. Some eruptions blasted material outward faster than a bullet. Material escaping Io formed a giant donut-shaped cloud around Jupiter called the Io plasma torus. Scientists eventually discovered the reason for Io's incredible volcanic activity: tidal heating. Io is trapped in a gravitational tug-of-war between Jupiter, Europa, and Ganymede. Their orbits are locked together in resonance. As Io travels around Jupiter, gravitational forces continuously stretch and squeeze the moon. Its surface flexes constantly. The ground literally rises and falls by hundreds of feet during every orbit. Imagine the Earth's surface moving vertically by the height of a skyscraper every single day. The friction generated by that flexing creates enormous heat inside. Enough heat to melt rock, enough heat to endless volcanic eruptions. Io became the most volcanically active world in the solar system. Humanity realized something important. Alien worlds were not dead. They were alive with geological activity. Then Voyager examined Europa. Europa looked completely different from Io. Smooth, bright, frozen. Its surface appeared covered in ice, crossed by enormous dark fractures stretching for thousands of miles. And once again, impact craters were strangely rare. Europa's surface also looked young. Something was reshaping it. But unlike Io, there were no volcanoes. Instead, the cracks resembled fractured sea ice on Earth. Scientists began considering an astonishing possibility. Europa's icy crust might be floating above a hidden global ocean, an ocean beneath the ice. Evidence quickly accumulated. Europa's density suggested large quantities of water beneath the surface. The crack patterns resembled sea ice floating on liquid water. Tidal heating from Jupiter could potentially keep water liquid below the frozen crust. Magnetic field measurements hinted at a conductive layer beneath the ice. possibly salty water. Scientists estimated Europa's hidden ocean might contain more liquid water than all oceans on Earth combined. An entire alien ocean hidden beneath frozen ice. And suddenly, one question became unavoidable. Could life exist there? On Earth, life exists almost everywhere liquid water exists. Deep underground, beneath Antarctic ice, around hydrothermal vents in complete darkness. Wherever water remains liquid, life often appears. If Europa possesses a long-lasting subsurface ocean, if energy sources exist on the ocean floor, then perhaps life could survive there too. Maybe simple microbial organisms hidden beneath miles of ice. Voyager completely changed how scientists thought about habitable worlds. Life no longer seemed limited to planets like Earth. Moons could be habitable too, even frozen moons far beyond the traditional habitable zone. Voyager continued revealing strange new worlds. Ganymede displayed enormous grooved terrain and complex geology. Callisto appeared ancient and heavily cratered. Then another surprise emerged. Jupiter had rings. Faint, thin, invisible from Earth, until Voyager discovered them. The discovery forced scientists to rethink planetary ring systems completely. If Jupiter had rings, perhaps all giant planets did too. And Voyager was only getting started. After leaving Jupiter behind, both Voyager spacecraft continued deeper into the outer solar system. Ahead of them waited Saturn. For centuries, Saturn had fascinated humanity more than any other planet. Even through primitive telescopes, people could see something strange surrounding it. Galileo first observed Saturn in 1610, but his telescope was too weak to properly resolve the rings. He described Saturn as looking like a planet with handles or ears attached to its sides. Later, as Saturn moved through its orbit and the rings changed angle relative to Earth, those handles disappeared completely. Galileo was confused. He could not understand how a planet's strange appendages could vanish and reappear. Decades later, better telescopes finally revealed the truth. Saturn was surrounded by rings, enormous rings, thin, flat structures orbiting the planet. Over time, astronomers learned more. They discovered gaps inside the rings, especially the large dark region, now known as the Cassini division. But nobody truly understood what the rings were like up close until Voyager arrived. Voyager 1 reached Saturn in November 1980. Voyager 2 followed in August 1981. And immediately, Saturn transformed from a distant object into an unbelievably complex world. The rings were not simple solid structures. They were made of countless particles orbiting Saturn independently. Ice, dust, rock fragments, tiny grains, large chunks, an entire system of orbiting debris stretching across space. From Earth, Saturn's rings looked like a few broad bands, but Voyager revealed something astonishing. The rings were actually composed of thousands upon thousands of narrow ringlets. Everywhere the cameras looked, new structures appeared. Tiny gaps, bright bands, dark bands, waves rippling through the rings, regions of different density. The closer Voyager looked, the more complicated the system became. Even the famous Cassini division was not truly empty. Inside the dark gap existed countless faint ringlets impossible to see from Earth. The entire ring system looked alive, dynamic, constantly shifting under the influence of gravity. Then, Voyager discovered features scientists never expected: braided rings. One narrow ring, known as the F ring, appeared twisted into multiple strands, like a cosmic rope. Scientists eventually realized two small moons, Prometheus and Pandora, were responsible. These moons orbited on opposite sides of the ring and acted as gravitational shepherds. Their gravity confined the ring particles into narrow structures, while also twisting and disturbing them into strange braided patterns. Voyager also observed mysterious dark spokes rotating across Saturn's rings. These spoke-like features stretched radially outward across the rings, like shadows on a wheel. At first, scientists were deeply confused. Ordinary solid structures should have been torn apart by orbital motion, because particles closer to Saturn orbit faster than particles farther away. Yet the spokes remained intact for hours. Eventually, scientists concluded the spokes were caused by electromagnetic forces. Tiny charged dust particles were being lifted above the rings by Saturn's magnetic field, forming temporary dark structures suspended over the ring plane. Saturn's rings were not static. They were active systems, shaped by gravity, collisions, and electromagnetic interactions. Then, Voyager revealed another astonishing fact. The rings were incredibly thin. In some regions, only about 30 feet thick. Think about that carefully. The rings stretched over 175,000 miles across. Yet vertically, some parts were thinner than a small building. An enormous structure with an almost impossibly tiny thickness. If Saturn's rings were scaled down to the size of a sheet of paper, they would be vastly thinner than the paper itself. Scientists realized the thinness revealed something important about the ring's history. Collisions between particles naturally flatten ring systems over time. Particles moving above or below the ring plane gradually collide and settle into the same orbit. The rings had likely been evolving for millions of years, yet they probably were not ancient. Micrometeorites constantly erode ring particles. Material slowly spirals down into Saturn's atmosphere in a process called ring rain. If the rings were billions of years old, they likely would not still exist. Scientists began suspecting Saturn's rings might actually be relatively young, perhaps formed when a moon wandered too close to Saturn and was ripped apart by tidal forces, the shattered debris spreading outward into rings. Voyager 2 flew so close to Saturn's rings that the spacecraft actually detected impacts from ring particles. Not sound, because space is silent, but tiny dust grains striking the spacecraft created electrical signals detectable by onboard instruments. Thousands of microscopic impacts every second, each dust grain tiny, yet traveling at enormous speed. The spacecraft survived without damage, but the data provided direct measurements of ring particle populations. Saturn itself was equally fascinating. The atmosphere contained enormous jet streams, with wind speeds exceeding 1,000 miles per hour. Cloud bands wrapped around the planet in soft golden colors. Storm systems churned deep inside the atmosphere. And hidden near Saturn's North Pole was one of the strangest atmospheric structures ever discovered. A giant hexagon. A perfectly shaped six-sided jet stream spanning roughly 20,000 miles across. Later analysis of Voyager images confirmed the feature was real. A gigantic atmospheric wave, somehow maintaining a stable hexagonal shape for decades. No other known planet possessed anything similar. Even today, scientists still study Saturn's hexagon, trying to fully understand how it remains stable. Voyager also examined Saturn's magnetic field. Unlike Jupiter's tilted magnetic field, Saturn's field aligned almost perfectly with the planet's rotation axis. The magnetic environment trapped charged particles and created radiation belts surrounding the planet. But Saturn's most important target was not Saturn itself. It was Titan. Titan was one of the greatest mysteries in the solar system. Even from Earth, astronomers knew Titan possessed a thick atmosphere. That alone made it extraordinary. Most moons are too small to retain atmospheres. Their gravity is too weak. But Titan held on to a dense atmosphere wrapped in thick orange haze. Visible light could not penetrate the haze. Nobody knew what Titan's surface looked like. Scientists only knew the atmosphere contained nitrogen and methane. Everything else remained unknown. Voyager 1 was specifically directed toward Titan. This decision carried enormous consequences. Flying close to Titan would permanently alter Voyager 1's trajectory. The spacecraft would be thrown upward out of the plane of the solar system forever. It would never visit another planet. The grand tour for Voyager 1 would end at Saturn. NASA accepted that sacrifice because Titan was considered too important to ignore. Voyager 1 passed within approximately 4,000 miles of Titan's surface, and the discoveries were astonishing. Titan's atmosphere was denser than Earth's. Surface pressure exceeded Earth's atmospheric pressure by roughly 50%. The atmosphere was composed almost entirely of nitrogen, very similar to Earth. But Titan was unimaginably cold, temperatures near -290 degrees Fahrenheit. At those temperatures, water becomes rock-hard ice. But methane behaves like water does on Earth. Voyager discovered methane clouds inside Titan's atmosphere. Scientists realized methane likely evaporated, condensed, and rained back onto the surface. Titan possessed its own weather cycle, not based on water, based on methane. Sunlight breaking apart methane molecules created more complex hydrocarbons inside the atmosphere. Organic chemistry unfolded continuously high above Titan's surface. Large molecules called tholins formed in the atmosphere and slowly drifted downward, creating the thick orange haze surrounding the moon. Scientists became fascinated. Titan resembled a frozen version of early Earth. Billions of years ago, before oxygen dominated Earth's atmosphere, our planet may have possessed methane-rich skies and active atmospheric chemistry similar to Titan's. Some researchers wondered whether Titan represented a natural laboratory, showing conditions similar to Earth before life emerged. Voyager could not directly see Titan's surface through the haze, but the atmospheric data painted a remarkable picture. Perhaps rivers flowed across the surface. Perhaps lakes existed. Perhaps seas of liquid methane covered parts of Titan. Maybe dunes made from frozen hydrocarbons stretched across the landscape. Years later, the Cassini mission confirmed many of Voyager's predictions. Titan truly possessed methane lakes and rivers, a complete alien hydrological cycle, one of the most Earth-like worlds ever discovered, yet utterly alien at the same time. After Saturn, Voyager 1's planetary mission officially ended. Titan's gravity had redirected the spacecraft upward, out of the ecliptic plane. Voyager 1 now headed northward, toward interstellar space. But Voyager 2 still had a choice. Mission planners had carefully designed its Saturn flyby to preserve the possibility of continuing toward Uranus. NASA debated whether the spacecraft should continue. Voyager had already exceeded its original design expectations. Could it survive another journey lasting years? Would the scientific discoveries justify the cost? Eventually, NASA approved the extension. Voyager 2 would continue. The spacecraft began a 4.5-year journey toward Uranus, and Uranus turned out to be one of the strangest planets in the entire solar system. Voyager 2 arrived at Uranus in January 1986. Immediately, scientists noticed something bizarre. Uranus was tilted sideways. Most planets rotate roughly upright relative to their orbit around the Sun. Earth tilts about 23 degrees, creating seasons, but Uranus tilts 98 degrees. The planet essentially rolls around the Sun like a giant spinning ball lying on its side. This creates the most extreme seasons in the solar system. Each pole experiences approximately 42 years of continuous daylight, followed by 42 years of darkness. When Voyager arrived, Uranus's south pole pointed almost directly toward the Sun. The planet appeared calm, almost featureless, a pale blue-green sphere floating in darkness. Methane inside the atmosphere absorbed red light and reflected blue-green wavelengths, creating Uranus's distinctive color. Voyager found relatively little atmospheric activity compared to Jupiter or Saturn, but the magnetic field shocked scientists. Uranus possessed a magnetic field tilted dramatically away from the planet's rotation axis. Even stranger, the magnetic field was offset from the planet's center. Nothing like Earth's magnetic field, nothing like Jupiter or Saturn. Scientists still struggle to fully explain why Uranus behaves this way. Voyager also discovered 10 previously unknown moons around Uranus, and among those moons, Miranda became one of the strangest objects ever observed. Miranda's surface looked shattered, massive cliffs, enormous canyons, chaotic terrain, regions that looked completely unrelated to neighbouring areas. Some scientists suggested Miranda may have been destroyed long ago by a giant impact before gravitationally reassembling itself. The moon looked broken and rebuilt incorrectly. Voyager also confirmed Uranus possessed dark, narrow rings, very different from Saturn's bright, icy rings. Then Voyager 2 began its final planetary journey toward Neptune, the farthest major planet from the Sun. The trip required another 3.5 years. Finally, in August 1989, Voyager 2 reached Neptune. And Neptune surprised everyone. Despite receiving almost no sunlight, Neptune possessed the most violent weather in the outer solar system. Enormous storms raged through the atmosphere. The Great Dark Spot appeared roughly the size of Earth itself. Winds exceeded 1,200 miles per hour, the fastest winds ever measured on any planet. Scientists immediately realized Neptune must contain a powerful internal heat source. The planet radiated far more heat than it received from the Sun. That internal heat drove Neptune's violent atmospheric circulation. Like Uranus, Neptune's atmosphere contained methane, creating a deep blue color. But Neptune's color appeared richer and more intense than Uranus's pale blue-green appearance. Voyager discovered Neptune also possessed a strangely tilted magnetic field, again offset from the planet's center, again unlike anything expected. The similarities between Uranus and Neptune suggested scientists were missing something fundamental about how magnetic fields form inside ice giant planets. Voyager then focused on Triton, Neptune's largest moon, and Triton immediately stood out as extraordinary. It orbited Neptune backward, a retrograde orbit. No other major moon in the solar system behaved this way. Scientists concluded Triton did not originally form around Neptune. It was probably a captured object from the Kuiper Belt, an ancient frozen world pulled into Neptune's gravity billions of years ago. Triton's surface temperature measured around -391 degrees Fahrenheit, one of the coldest places ever visited. Yet even Triton was active. Voyager discovered geysers erupting nitrogen gas high above the frozen surface. Dark material blasted upward into the thin atmosphere. Even at unimaginable cold temperatures, geological activity still existed. Neptune also possessed rings, faint dark rings similar to Uranus. By the end of Voyager 2's Neptune encounter, humanity's understanding of the outer solar system had been completely transformed. 4 giant planets, dozens of moons, volcanoes, subsurface oceans, alien atmospheres, methane weather, violent storms, planetary rings around every gas giant. Nothing matched humanity's original expectations. Every world turned out stranger than scientists imagined. But Voyager's greatest mission was only beginning. After Neptune, both spacecraft continued outward towards something humanity had never directly explored before: the edge of the solar system itself. After Neptune, the planetary phase of the Voyager mission was finally complete. 12 years earlier, the spacecraft had launched from Earth with a mission expected to last only 5 years. Now both probes had travelled across the outer solar system, visited 4 giant planets, explored dozens of moons, and transformed planetary science forever. But neither spacecraft was dead. Both Voyagers were still functioning, still sending data, still travelling outward at incredible speed. And scientists realised something extraordinary. Voyager could continue exploring a region no spacecraft had ever reached before. the boundary between the solar system and interstellar space. To understand what Voyager eventually discovered, you first need to understand the solar wind. The sun does not only produce light and heat, it constantly releases streams of charged particles into space, mostly protons and electrons. These particles flow outward in every direction at enormous speed. This continuous outflow is called the solar wind. The sun's outer atmosphere, called the corona, is unbelievably hot. Temperatures exceed 1 million degrees Celsius. At those temperatures, particles gain enough energy to escape the sun's gravity entirely. The solar wind travels through the solar system at speeds between roughly 300 and 500 miles per second. Even though the solar wind is extremely thin, only a few particles per cubic centimetre near Earth, it extends unbelievably far into space. Every second, the sun loses roughly 1 million tons of material through the solar wind. As the solar wind moves outward, it drags the sun's magnetic field along with it. Together, the particles and magnetic field create an enormous protective bubble surrounding the solar system. This bubble is called the heliosphere. The heliosphere extends far beyond the planets, far beyond Neptune. It acts like a shield, protecting the inner solar system from much of the radiation and energetic particles traveling through interstellar space. But the heliosphere is not perfectly round. The sun itself moves through the galaxy at roughly 43,000 miles per hour relative to nearby interstellar clouds. As the solar wind pushes outward while the sun moves forward, the heliosphere becomes compressed at the front and stretched into a long tail behind the sun, like the wake behind a ship moving through water. As the solar wind travels farther from the sun, it eventually reaches a region where the pressure of interstellar space pushes back strongly enough to slow it down dramatically. Before reaching this boundary, the solar wind travels faster than the speed of sound in plasma, supersonic flow. Then, suddenly, it slows below the speed of sound. This region is called the termination shock. The solar wind becomes compressed, turbulent, and heated. Beyond the termination shock lies a chaotic region called the heliosheath. Here, solar particles begin mixing with particles from interstellar space. The magnetic field becomes tangled, the environment becomes unstable and turbulent. And finally, beyond the heliosheath lies the outer boundary itself, the heliopause, the place where the sun's influence effectively ends. Beyond the heliopause lies interstellar space, the space between stars, a region no human-made object had ever entered. Scientists had only theoretical estimates for where the heliopause might exist, perhaps somewhere between 80 and 120 astronomical units from the sun. 1 astronomical unit equals the distance between Earth and the sun, about 93 million miles. Neptune orbits around 30 astronomical units away. The heliopause existed far beyond even the outermost planets. Voyager was heading directly toward it. Voyager 1 crossed the termination shock in December 2004. At that moment, the spacecraft was approximately 94 astronomical units from the Sun, roughly 8.5 billion miles away. Its instruments detected sudden, dramatic changes. The solar wind slowed sharply. Temperatures increased. The magnetic field became stronger and more chaotic. Voyager had entered the heliosheath. For years afterward, Voyager 1 continued travelling through this strange transitional region. Scientists watched carefully for signs that the spacecraft was approaching the heliopause itself. One of the most important clues involved cosmic rays. Cosmic rays are extremely energetic and happening. In 2012, Voyager started detecting sudden, temporary jumps in cosmic ray levels. The increases would last for days or weeks before fading. Scientists realized the heliopause itself was moving. Like waves on a shoreline, the boundary shifted inward and outward depending on solar activity and pressure from interstellar space. Sometimes Voyager briefly crossed into interstellar space before returning to the heliosheath again. Then came August 25th, 2012. Everything changed. Cosmic ray intensity suddenly jumped dramatically. At the same time, low-energy particles originating from the Sun almost completely disappeared. And unlike previous fluctuations, the changes did not reverse. Days passed. Weeks passed. The readings remained stable. Voyager 1 had crossed something major, but scientists initially hesitated to announce the discovery. One detail created confusion. The magnetic field direction did not change as much as some models predicted. Many researchers expected the interstellar magnetic field to point in a very different direction from the Sun's magnetic field. Yet Voyager's magnetometer showed surprisingly similar alignment. Debate erupted. Had Voyager truly entered interstellar space? Or had it merely entered another strange region inside the heliosphere? The answer finally came from Voyager's plasma wave instrument. In 2013, the instrument detected oscillations traveling through the plasma surrounding the spacecraft. By analyzing the waves, scientists could calculate plasma density around Voyager. Inside the heliosheath, plasma density was extremely low, but the new measurements showed densities roughly 40 times higher. Exactly what scientists expected in interstellar space. The conclusion became unavoidable. Voyager 1 had crossed the heliopause. Humanity's first machine had officially entered the space between stars. NASA announced the discovery in September 2013. A spacecraft launched in 1977, originally designed to survive 5 years, had become the first human-made object to leave the solar system. At the time, Voyager 1 was over 11 billion miles away. Radio signals traveling at light speed required more than 16 hours to cross the distance. A single conversation with Voyager now took more than a full day. Voyager 2 crossed the heliopause 6 years later, in November 2018. Its crossing was even clearer, because Voyager 2 still carried a functioning plasma science instrument capable of directly measuring the solar wind. One day, the solar wind was present. The next day, it vanished completely. Cosmic rays increased sharply. Plasma density jumped. Voyager 2 had also entered interstellar space. Both spacecraft now traveled beyond the Sun's protective bubble. Both explored a region humanity had never directly sampled before. And even there, Voyager continued surprising scientists. The heliopause was not smooth or stable. Particles leaked across the boundary in both directions. Solar particles escaped outward, interstellar particles drifted inward. Magnetic fields tangled together. The boundary resembled a chaotic transition zone rather than a clean dividing line. The interstellar magnetic field proved stronger than expected. The surrounding plasma was hotter and denser than predicted. Voyager was teaching humanity about the local galactic environment for the very first time. For decades, scientists had only studied interstellar space indirectly through telescopes. Now humanity possessed instruments directly measuring the plasma, magnetic fields, and particles between stars. Voyager became humanity's first interstellar explorer, but the spacecraft carried something else, something deeply emotional. Attached to both Voyager probes was a golden record, a 12-inch gold-plated copper disc containing sounds, images, greetings, and music from Earth. The idea came largely from astronomer Carl Sagan and a small team assembled to create humanity's message to the cosmos. The team had less than a year to design the record before launch, and they faced an impossible question. If another intelligent civilization someday found Voyager, what should humanity say? What sounds represent Earth? What images represent human civilization? How do you describe an entire planet to beings who may know nothing about humanity? The team decided the record should contain many different kinds of information. Greetings in 55 languages, simple messages of peace and goodwill, natural sounds from Earth: thunder, rain, ocean waves, wind, birdsong, whales, dogs barking, footsteps, laughter, a baby crying, heartbeats. Music from cultures around the world, classical compositions by Bach, Mozart and Beethoven, traditional music from Asia, Africa, South America and indigenous cultures, blues, jazz, rock and roll, music representing humanity's emotional and cultural diversity. The record also contained 115 encoded images, mathematical diagrams, scientific formulas, the structure of DNA, human anatomy, landscapes, animals, plants, microscopic life, human families, architecture, cities, transportation, technology, the diversity of Earth itself. The cover included instructions showing how to play the record. The instructions used universal scientific symbols rather than human language, binary numbers, physical constants, astronomical references. The cover also contained one of the most remarkable maps humanity ever created, a pulsar map. Pulsars are rapidly rotating neutron stars emitting precise pulses of radio waves. Each pulsar rotates at a unique rate. The record's cover showed the position of 14 pulsars relative to the Sun, along with their pulse frequencies encoded in binary. An advanced civilization could theoretically use the map to locate Earth's position in the galaxy and determine when the spacecraft launched. The Golden Record became humanity's message to eternity. The odds of another civilization ever finding Voyager are almost unimaginably small. The galaxy is enormous. Stars are separated by vast distances, measured in light years. Voyager is tiny, a small machine drifting through incomprehensible emptiness. Even if intelligent civilizations exist elsewhere in the galaxy, the probability of Voyager ever being discovered is extraordinarily low. Yet the record may survive for billions of years, long after Earth changes beyond recognition, long after humanity disappears. Long after the Sun dies, Voyager may still exist. The vacuum of space contains no oxygen or water to corrode the record. The gold plating may preserve it almost indefinitely, and perhaps someday, far in the future, another civilization might encounter this tiny artifact drifting through the galaxy. They might decode the images, listen to the music, hear humanity's greetings, learn that once, around a small yellow star, a species called humans looked upward at the universe and wondered if anyone else existed. But the Golden Record was never truly about aliens. It was about humanity itself. It was a declaration, a statement saying, we were here, we explored, we wondered, we created beauty. We reached outward into the darkness, hoping someone, somewhere, might someday know we existed. Then, in 1990, Voyager performed one final historic act. At Carl Sagan's request, NASA agreed to turn Voyager 1's cameras back toward the inner solar system for one last series of photographs. The maneuver carried risks. Pointing the cameras near the Sun could damage them permanently, and Earth would appear unimaginably small from Voyager's distance. But NASA approved the request. Voyager rotated slowly, then photographed the planets from nearly 4 billion miles away. One image showed Earth, a tiny pale blue dot suspended inside a beam of scattered sunlight. Less than a pixel, almost invisible. Carl Sagan later reflected on the image in his book Pale Blue Dot. He described every human being who ever lived existing on that tiny point of light. Every civilization, every war, every religion, every love story, every dream, every triumph, every tragedy, all on a fragile speck floating in cosmic darkness. The image transformed humanity's perspective forever. From Voyager's distance, Earth's divisions vanished. No borders. No nations. Only a tiny, vulnerable world, alone in the vast universe. After taking the photographs, Voyager's cameras were shut down permanently to conserve power. The spacecraft continued onward into darkness. Today, Voyager 1 remains the most distant human-made object ever created. As of 2026, it travels more than 15 billion miles from Earth. Voyager 2 follows behind on a different path. Both spacecraft continue moving outward forever. The plutonium inside the RTGs slowly decays, producing less power every year. NASA engineers carefully shut down instruments one by one to extend the mission. Eventually, the spacecraft will fall silent, the final signal will fade, and humanity will lose contact forever. But Voyager itself will continue, drifting endlessly through the galaxy, long after Earth is gone, long after the Sun becomes a white dwarf, long after human civilization disappears. Voyager will still carry the golden record through interstellar darkness. An eternal message from a species that once looked up at the stars and dared to explore. Even after nearly 50 years, the Voyager mission still feels unreal. Two machines, launched in the 1970s, built using technology less powerful than a modern smartphone, have traveled farther than anything humanity has ever created. They crossed the outer solar system, visited worlds nobody had ever seen, entered interstellar space, and they are still moving tonight, still traveling through darkness billions of miles from Earth, still carrying humanity's voice into the galaxy. When scientists look back at Voyager's discoveries, it becomes clear that the mission completely changed planetary science forever. Before Voyager, the outer solar system was mostly mystery. Telescopes showed blurry disks of light. Astronomers knew basic facts about Jupiter, Saturn, Uranus, and Neptune, but the details remained hidden. Nobody understood how dynamic those worlds truly were. Nobody expected volcanic moons. Nobody expected underground oceans. Nobody expected methane weather systems. Nobody expected active geology on frozen worlds billions of miles from the Sun. Voyager shattered old assumptions. Jupiter transformed from a giant striped planet into a violent world dominated by storms, radiation belts, and complex atmospheric physics. Its moons became worlds of their own. Io changed how scientists viewed moons entirely. Before Voyager, moons were usually imagined as dead objects, cold, ancient, inactive. But Io proved otherwise. A moon could remain violently alive for billions of years if tidal forces continuously heated its interior. Voyager showed humanity a world covered in sulfur volcanoes, erupting constantly beneath Jupiter's enormous gravity. And then came Europa, perhaps Voyager's most important discovery for the future search for life. The realization that a frozen moon might hide a global ocean beneath its icy shell changed everything. For generations, scientists mostly searched for life on planets similar to Earth. Planets located inside the habitable zone around stars, where liquid water could exist on the surface. But Europa revealed another possibility. Life might survive beneath ice, protected from radiation, heated by tidal forces, sustained by hydrothermal activity deep below an alien ocean. That discovery expanded the potential locations for extraterrestrial life enormously. Suddenly, habitable environments might exist throughout the galaxy, not only on planets, but on moons orbiting giant worlds. Later missions strengthened Voyager's discoveries. The Galileo spacecraft gathered additional evidence supporting Europa's hidden ocean. Scientists found signs suggesting salty water beneath the ice crust, possibly in direct contact with a rocky seafloor. On Earth, similar environments around hydrothermal vents support entire ecosystems without sunlight. If Europa possesses comparable conditions, then perhaps life exists there right now. Not intelligent life. Probably microscopic organisms. But even microbial alien life would completely change humanity's understanding of biology and our place in the universe. Voyager also revealed the incredible complexity of Saturn's system. Before Voyager, Saturn's rings appeared elegant but relatively simple. After Voyager, scientists realized the rings formed one of the most complicated structures in the solar system. Thousands of ringlets, density waves, shepherd moons, electromagnetic spokes, braided structures. The rings became a natural laboratory for understanding gravity and orbital mechanics. Voyager also transformed Titan from a mysterious orange blur into one of the most fascinating worlds known. Titan's thick atmosphere, methane lakes, weather systems, and organic chemistry made it feel eerily Earth-like, while remaining profoundly alien. Some scientists believe Titan resembles a frozen version of ancient Earth before life emerged. A world where chemistry continuously experiments with organic molecules beneath orange skies. Even today, Titan remains one of the most important targets in planetary science. Future missions may eventually land drones or floating probes on Titan's surface. All of that interest began with Voyager. Then came Uranus and Neptune. Before Voyager, humanity had never seen these distant planets up close. Uranus revealed bizarre sideways rotation and distorted magnetic fields. Neptune revealed violent storms, despite receiving almost no solar energy. Triton revealed active geysers erupting from one of the coldest surfaces ever explored. Every planet Voyager visited turned out stranger and more complex than expected. That became one of Voyager's greatest lessons. Nature is always more creative than human imagination. Every time scientists thought they understood the solar system, Voyager revealed something unexpected. The mission also taught humanity something important about engineering. Voyager was designed for 5 years. 5. Yet the spacecraft continued functioning for nearly half a century. That longevity represents one of the greatest engineering accomplishments in history. Thousands of people contributed to Voyager's survival. Engineers designing redundant systems, programmers writing autonomous fault protection software, scientists planning observations, technicians operating the deep space network. Every detail mattered. And somehow, decades later, the spacecraft still works, still communicating across unimaginable distances.
Alcyonius, a
Even
modest
today,
elliptical
NASA
galaxy,
engineers
sits
continue
quietly in
making
the cosmic
careful
web,
decisions
but in
about which
radio light,
instruments to
it's
keep
the structure
operating.
stretching 16
Power
million light
levels
years,
slowly decline
dwarfing its
each
host.
year as the plutonium
Alcyonius,
inside the RTGs
a seemingly
decays.
ordinary
The
elliptical
spacecraft no
galaxy
longer
is
has
false.
enough electricity to power everything
Its radio
simultaneously.
structure reveals
So
the
mission
enormous
teams shut down
statistical
instruments one at a time
Alcyonius
to
appears
extend
as a
Voyager's
modest
life.
elliptical galaxy in
Every
optical
remaining
light, but in
watt
radio light,
matters.
its plasma black
Eventually,
hole travel at
probably
stretching
sometime
light
during the
sucos,
2030s,
inflating these colossal
Voyager
structures.
will lose the ability to operate scientific instruments entirely. The spacecraft may continue transmitting a single carrier signal for a while afterward, a faint electronic heartbeat proving it still exists. Then, eventually, silence. The final signal will fade. The Deep Space Network will stop hearing Voyager forever, and one of humanity's greatest exploratory missions will officially end. But Voyager itself will continue. Nothing significant exists in interstellar space to slow it down. No atmosphere, almost no friction, only weak gravitational forces from distant stars. Voyager will drift through the galaxy for millions, perhaps billions of years. The spacecraft has effectively become an artificial comet, an interstellar wanderer. Long after humanity disappears, Voyager may still exist. Long after Earth becomes uninhabitable. Long after the sun dies. The sun itself will eventually exhaust its hydrogen fuel roughly
In the
5
cosmic web,
billion
a
years
brilliant
from now.
giant galaxy
It will
holds court.
expand
Its
into a
gravity
red giant
inexorably
star.
pulls in smaller neighbors.
Mercury and
Tidal
Venus
forces
will
stretch
likely
and tear
be
them
destroyed.
apart.
Earth
Earth,
may also
Andromeda
be
is a faint
consumed,
smudge in
or
the
at
night
least
sky.
transformed into a
In deep
scorched,
space,
lifeless
traffic
world.
Eventually,
Eventually, the sun will shed its outer layers and
from
collapse
Earth
into a
orbiting
white
the sun,
dwarf,
we
a
zoom out
dense
through the Milky
stellar
Way.
ember, slowly
Its
cooling
arms
in
are filled
darkness.
with billions of stars
And Voyager?
and vast empty
Voyager
spaces.
may still be out
From
there,
Earth orbiting
still
the sun,
orbiting
we
the
zoom
center
out
of the
into
Milky
the
Way
vast
galaxy,
Milky Way. Billions
still
of
carrying
stars
the golden
separated
record,
by vast empty
still
spaces.
preserving
The
sounds
nearest
and
star,
images from a
distant
civilization
light.
that no longer exists. That idea gives Voyager an almost haunting quality. The spacecraft became more than a scientific mission. It became a time capsule, a message from humanity to the distant future. Perhaps someday, millions or billions of years from now, another civilization
From Earth
might encounter
orbiting our
Voyager.
sun, we zoom out to
The
reveal
odds
the
are
Milky Way,
extraordinarily small.
a vast
The
bar
galaxy is
spiral light
unimaginably
travels
large.
across its emptiness
Voyager
between billions
is
of
tiny.
stars. The Milky Way
Yet, the
galaxy,
possibility
our cosmic
exists.
home, floats in the infinite.
Another intelligence might someday retrieve this silent, drifting machine. They might study the golden
From Earth
record,
orbiting our sun, we
decode
journey
the
to the Milky
diagrams,
Way, a
play
vast
the
galaxy of
sounds,
billions of
hear
stars.
music from
A
Earth,
beam of light. The nearest
see
star would be
images of
separated by a
oceans,
vast dark
forests,
chasm.
animals,
From Earth
and
orbiting
human
our sun,
faces.
we zoom out to
And they
reveal the
might
vast
learn
Milky
that
Way.
once, around a distant
A beam
star,
new travels
a
across its
species
vast,
called
with the nearest
humanity
star
existed.
distant.
A species curious enough to build machines capable of crossing interstellar space. But even if nobody ever finds Voyager, the mission still matters deeply. Because the Golden Record was never only about aliens. It was really about us. About humanity deciding what deserved to represent our civilization. What music mattered. What images mattered. What sounds defined Earth. The record became a portrait of humanity itself. A declaration that knowledge, beauty, art, science, and exploration matter. That human existence mattered. Carl Sagan understood this deeply. For him, Voyager represented humanity reaching outward into the cosmos, not with weapons or conquest, but with curiosity, with wonder, with hope. That spirit reached its emotional peak with the pale blue dot photograph. February 14th, 1990. Voyager 1 had already passed Neptune and was heading toward the outer solar system. At Sagan's request, NASA commanded the spacecraft to turn around one final time. From nearly 4 billion miles away, Voyager photographed Earth. The result became one of the most important images ever captured. Earth appeared as a tiny pale blue dot suspended inside a ray of sunlight, less than a single pixel, almost nothing, and yet everything humanity had ever known existed on that tiny point. Every civilization, every empire, every religion, every scientific discovery, every human relationship, every war, every act of kindness, every dream, all on a tiny, fragile world floating in cosmic darkness. The image forced humanity to confront perspective. From space, Earth's divisions disappear. Borders vanish, politics vanish. Human conflicts suddenly appear painfully small. The pale blue dot became a reminder of both humanity's fragility and unity. Sagan described Earth as a mote of dust suspended in a sunbeam, a tiny world alone in a vast universe. And perhaps that is Voyager's greatest gift: perspective. Voyager showed humanity that the universe is larger, stranger, and more beautiful than we imagined. But it also showed us ourselves. It showed us that humans are capable of extraordinary things. We can build machines that survive for decades in deep space. We can explore planets billions of miles away. We can cross the boundary between stars. We can send part of ourselves into the cosmos. Voyager proved exploration matters, not because it generates profit, not because it conquers territory, but because understanding the universe changes us. The mission cost less than many military projects humans barely remember today, yet Voyager fundamentally transformed humanity's understanding of reality. It inspired generations of scientists, engineers, astronomers, and dreamers. Many people working on modern space missions grew up watching Voyager's discoveries unfold. Missions like Cassini, Juno, and New Horizons all exist partly because Voyager proved what exploration could achieve. And Voyager's story is not really finished. Tonight, both spacecraft are still out there, still traveling, still carrying the golden record, still exploring interstellar space. Voyager 1 currently moves at roughly 35,000 miles per hour. Voyager 2 slightly slower. Both are escaping the sun forever. Neither spacecraft will ever return. They are now travelers of the galaxy itself. Perhaps someday humans will send faster interstellar probes. Perhaps future spacecraft will surpass Voyager's distance. Maybe one day humans themselves will leave the solar system, but Voyager will always remain first. The first machines to cross into interstellar space, the first ambassadors of Earth to the galaxy. And there is something deeply poetic about that. Two small machines launched in 1977, still alive tonight, still whispering across billions of miles of darkness, still carrying greetings from Earth into the endless cosmic ocean. Voyager represents the best side of humanity: curiosity, ingenuity, persistence, the desire to understand, the courage to explore places nobody has ever seen before. When humanity looks back centuries from now, Voyager will likely remain one of the defining achievements of our civilization, because Voyager did something extraordinary. It crossed the edge of the known world and kept going. And somewhere tonight, beyond the planets, beyond the heliosphere, beyond the edge of the sun's influence, two tiny spacecraft are still moving through interstellar darkness, still carrying humanity's message, still representing us to the universe. Voyager 1 and Voyager 2. Two machines that changed forever how humanity sees the cosmos. And their journey has only just begun.